Hello बच्चों, let's read this question. So the question says 1 gram at a sample of calcium carbonate was strongly heated and the carbon dioxide liberated was absorbed in 100 ml of 0.5 molar NaOH. Assuming 90% purity for the sample, how much ml of 0.5 molar HCl would be required to react with the solution of the alkali to reach the phenolphthalein endpoint? And we have 4 options over here. So here the key concept is concept of chemical equivalence. Chemical equivalence. Alright. So यहाँ पर दिया गया है that we are heating a sample of calcium carbonate. So this is calcium carbonate which upon heating gives out calcium oxide and carbon dioxide. Now carbon dioxide को हम react करवा रहे हैं NaOH के साथ. Alright. Then it gives us NaHCO3. But जो rest of the sodium hydroxide बच जा रही है, so remaining NaOH, we are titrating it with the given HCl solution, that is 0.5 molar HCl solution. Alright, so now let us first calculate the number of moles of calcium carbonate. So number of moles of calcium carbonate is equal to given mass divided by molar mass. So given mass है 1 gram divided by molar mass. Calcium carbonate की जो molar mass होती है that is 100 grams per mole. 100 grams mole inverse. And from this we will get 0.01 moles. Alright. So this is the number of moles of calcium carbonate. Now the purity is 90%. That means the number of moles of carbon dioxide will be 90% of the number of moles of calcium carbonate, because 1 mole of calcium carbonate से 1 mole of carbon dioxide निकलनी चाहिए. But अगर sample 90% pure है, then 1 mole of carbon dioxide, 1 mole of calcium carbonate से 0.9 moles of carbon dioxide निकलेगा. Alright, so number of moles of carbon dioxide liberated is equal to 90 divided by 100 multiplied by 0.01, that is 0.009 moles. Alright, this is the number of moles of carbon dioxide liberated. Now this is absorbed in 100 ml of 0.5 molar NaOH. So let us first calculate the number of moles of NaOH. So number of moles of NaOH is equal to molarity multiplied by volume. Molarity multiplied by volume, and ये volume liters में होनी चाहिए. Alright, so molarity given is 0.5 moles, 0.5 molar multiplied by volume. 100 ml given है, so 100 ml को अगर हम liters में convert करेंगे, then that is 0.1 liter, and then the number of moles of NaOH will be 0.05. Alright, so from the reaction between carbon dioxide and NaOH, we can see that CO2 plus NaOH gives NaHCO3, and from this we can see 1 mole of carbon dioxide reacts with 1 mole of NaOH. Alright, so number of moles of NaOH consumed by carbon dioxide will be equal to the number of moles of carbon dioxide, because 1 mole of carbon dioxide के साथ 1 mole of sodium hydroxide react कर रही है. So number of moles of NaOH consumed by carbon dioxide will be equal to the number of moles of carbon dioxide liberated, that is equal to 0.009. So number of moles of NaOH left, that is equal to number of moles of NaOH present previously, that is 0.05, minus number of moles of NaOH consumed, that is 0.009, 0.009, and this is equal to 0.041. Alright, so 0.041 moles of sodium hydroxide present है अभी, जिसको कि हमें 0.5 मोलर HCl के साथ titrate करना है. Alright, now again we know that HCl reacts with NaOH to give NaCl plus H2O, and here one equivalent of HCl is reacting with one equivalent of NaOH. So we can say that number of equivalents of HCl is equal to number of equivalents of NaOH, and यहाँ पर HCl एक acid है and sodium hydroxide base है, and दोनों के लिए जो N factors हैं वो 1 है, क्योंकि जो HCl है that is a monobasic acid और उसकी basicity 1 है, and इसीलिए इसकी N factor 1 है, and this base जो सोडियम हाइड्रोक्साइड है ये इस बेस की एसिडिटी 1 है, बिकॉज ये सिर्फ एक ही OH माइनस आयन डोनेट कर सकती है. सो हियर फॉर दिस बेस आल्सो द N factor is equal to 1. So we can write number of equivalents of HCl is equal to number of moles of HCl multiplied by N factor, which is equal to number of moles of NaOH multiplied by the N factor, और दोनों के N factor 1 है. So if we put these values, that's multiplied by 1, and here also this is multiplied by 1, then this will be the same value. So number of moles of HCl is equal to number of moles of NaOH, and number of moles of HCl हम calculate कर सकते हैं molarity multiplied by volume, and this is equal to the number of moles of NaOH जो कि हम find out किए थे, which is equal to 0.041. Alright, so 0.041, and molarity of HCl solution हमें पता है, that is 0.5 molar, and volume हमें find out करना है. Alright, 0.5 molar multiplied by V, that is equal to 0.041, and if we calculate the value of V, then V will be equal to 0.041 divided by 0.5, and then this is equal to 0.082 liters, and if we convert it into milliliters, then this will be equal to 82 ml. So 82 ml of 0.5 molar HCl will be required to react with the remaining NaOH. So 82 ml is correctly given in option number C. So our correct answer is option number C. This is the required solution, and I hope you understood the concept well. Best of luck.